we are going to be looking at elements and atoms. You should have your notes to fill out as well as your periodic table with you. You will be needing both of those. We are going to be looking at properties that are used to identify matter. Matter is anything that takes up space and has mass, and a property is a characteristic of a substance. Matter can be classified based on its physical properties. Physical properties are any property that can be observed without changing the chemical structure of the substance. Examples of physical properties are things like color, density, and conductivity. Another kind of property that chemicals or matter can be classified on is chemical properties. Chemical properties describe any possible chemical change elements can undergo. A new substance is always produced, and the new substance has different properties. Matter is classified based on the types of atoms and how they are arranged. Matter can be broken down into two broad categories: pure substances and mixtures. A pure substance is something that is identical in every sample. Pure substances can further be broken down into two different categories: elements and compounds. An element is something that cannot be broken down into anything simpler. A compound is made of two or more elements. Mixtures are made up of two or more substances. Three different types of mixtures are mechanical, suspension, and solution. Now some definitions. Mixtures are formed when two or more substances are put together but are not chemically combined. Properties of the substance do not change. Elements are substances that cannot be broken down into simpler materials. They are made up of atoms. Compounds are substances formed from two or more elements, where the elements are always combined in the same fixed proportions. If you take out your periodic table, we're going to look at the symbols for the elements. The symbols are always based on the Latin or English name. The symbols are always made of one or two letters, and the first letter is always a capital letter, and the second letter is always lowercase. Symbols are used to write chemical formulas. If you look at your periodic table, in the first row there is hydrogen. The symbol for hydrogen is a capital H. In the second row, right beneath hydrogen, is lithium. Lithium symbol has two letters, capital L and a lowercase I. Most elements can be found in nature as single atoms. Examples are iron, sodium, and carbon. Symbol for iron is Fe. Symbol for sodium is Na, and the symbol for carbon is C. Some elements will never be found in nature as single atoms. Examples are oxygen and hydrogen. They always exist as what is called a diatomic molecule. Oxygen gas always exists as O2. Same with hydrogen, always exists as H2. You will need to know what elements always exist as diatomic molecules. These are nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. Looking on your periodic table, you will notice that these elements form a 7 in the top right corner, starting with nitrogen, moving across to oxygen and fluorine, and then moving down that column, chlorine, bromine, and iodine. The only exception not in this magic 7 is hydrogen. Now we are going to look at atomic structure. You know that an atom is the smallest particle of an element that can exist by itself. And the nucleus of an atom contains all of its mass. Electrons orbit around the nucleus in energy shells or orbitals. The electrons can move from one atom to another. They can be shared amongst atoms, or they can be exchanged between atoms. Because electrons carry a charge and can move, they are the basis of electricity. Atomic number of an element is determined by the number of protons in each element. Atomic number is unique to each element. It is like the element's fingerprint, and it is what identifies that element. For example, carbon has an atomic number of 6. This means that carbon always has 6 protons. The mass number is the mass of an element. Mass number is the number of protons plus the number of neutrons added together. Atomic mass is the average mass of the atoms of an element. A note about the mass of subatomic particles. Protons and neutrons can be considered to have the same mass. Electrons are much smaller, at only 1/1800th the mass of a proton. This is why electrons are not factored in to calculating the mass. The last thing we are looking at today is board diagrams. This is an example of a board diagram, and this particular one is of sodium. Here you can see the electrons on the orbitals. You have 2 electrons on the inner orbital, 8 in the next, and up to 8 in the third one. This is sodium, which only has 11 electrons in total. So there are 2 on the inner shell, 8 in the next, and then just 1 electron in the third shell.